example is a problem in which we have a set of items. In this case, this is about a club that has an open mic night. People sign up to perform, and then the order of the acts is determined by randomly selecting names out of a hat, right? So you can imagine them writing down the names of each performer, putting them into a hat, and then pulling out one at a time. And so on this particular night, we have 5 performers who have signed up for slots, and we want to know in how many different orders could these 5 acts be selected to perform. So in other words, who's going to go first, who's going to go second, who's going to go third, fourth, and last? Like how many different ways could we assign people to those slots? So we can kind of imagine that you're like the club manager, and you throw those 5 names into a hat, and you've got you want to set up an order of 5 people performing. When you think about going to choose the first name that's going to go on your list, you're going to reach in the hat and pull out a slip of paper with a name on it. There's 5 different slips of paper in the hat, right? Let's say that our performers, we'll just call them A, B, C, D, and E, right? Let's say those are their first initials. When you go to choose person number 1, like inside of that hat, we have all 5 of them available. And so we have 5 possible choices for that first slot. And let's say that we choose person A, right? They end up in slot number 1. They're going to go first. Then when I go to choose the second person, I've already selected one of them. They're not going to get to go again. And that means that I've only got 4 choices left, right? When I go to make my second selection, I have 4 people I could choose from. And let's say that I choose person B for that second position, right? Now when I go to choose the third position, I have 3 people remaining to choose from. Any one of them, could randomly be chosen for the third position. And you can probably see here how the pattern is going to go, that for the 4th position, there will be 2 possible choices left. And then when we get down to the very end, there will be 1 person whose name will be remaining in the hat. Now, we kind of considered the possibility where person A was chosen for that first slot, but really it could have been any of those 5 people. And if we think back to the first example that we did with the tree diagram, we could draw out a similar kind of a thing for this type of problem. What we're going to do here to figure out how many total ways we could arrange these 5 people is we're going to multiply together all of these numbers of choices, right? Because we're going to select this first person and the second person and the third person. This is really kind of an and situation. And so the total number of arrangements is going to be the product of all of these numbers of choices. And so that will be 5 times 4 times 3 times 2 times 1. And it works out this way because, we're arranging all of the items in this group, or in this case, all of the performers who have signed up are getting arranged. And so we're going to multiply from 5 down to 1. This kind of calculation gets done quite often in counting and probability problems. And it actually gets done enough that it gets its own special symbolism. And this is nice to have because you can imagine, this kind of multiplication can get big pretty quickly. If we were to start at, say, 8 or 9 and multiply all the way down to 1, that's going to give us a really big number. That's a lot of multiplying to do. So we use a symbol that looks like an exclamation point. We call that a factorial symbol. And the factorial symbol, you'll find that on buttons on your calculator. It means to do just this, to take whatever number is in front of that symbol and multiply it by every smaller number until we get down to 1. And if you were to do this on your calculator, type in 5 factorial, or if you were to do 5 times 4 times 3 times 2 times 1, you would see that this comes out to be a total of 120. So there are 120 different ways that we could take those 5 people who signed up for the open mic night, and arrange them in order from first to last.